All right, so today we're diving deep into artificial intelligence.
Sounds exciting.
Yeah, we've got a ton of material to cover and really want to get to the bottom of it, right? Like what is this AI thing,
Yeah.
Where did it come from? Where is it going? That kind of stuff.
Yeah, I think a lot of people hear about AI, but they don't really understand like the core concepts, right? So I think our goal is to really like break it down and help people um kind of see the bigger picture
Exactly.
and not get lost in all the hype.
Yeah, yeah, for sure. So it feels like AI is kind of everywhere these days, right? Like it's in the news all the time. Everyone's talking about it. But, it's not really a new thing, is it? Like the roots of this go way back.
Yeah, you're absolutely right. It's not a new phenomenon. The real spark, I'd say, happened with the creation of the first modern computer back in 1943. That's when people really started seriously thinking about, well, can machines think? Is it possible to build something that has intelligence?
Yeah, like all of a sudden it wasn't just a philosophical question anymore.
Oh, exactly. And then in 1950, we have Alan Turing, brilliant guy,
Oh, yeah, Turing.
writes this incredibly influential paper called Computing Machinery and Intelligence, where he basically says, you know what? Let's stop arguing about what intelligence is and let's focus on what it does. Like, if a machine can behave in a way that's indistinguishable from a human, can we really say it's not intelligent?
And that's where the Turing test comes in.
Right.
Yeah.
Now, most people probably picture this like a robot trying to trick you into thinking it's a person, which is sort of the pop culture image.
Yeah, yeah.
But the practical applications are much more about, like, can an AI play chess at a grandmaster level?
Right.
Can it diagnose a disease as accurately as a doctor? It's about the outcome, not necessarily mimicking every single thing a human does.
Right. Like, can it perform the task?
Yeah.
Essentially, regardless of how it does it.
Exactly. And then you have John McCarthy in 1956, who really cements this idea, defining AI as machines that can perform tasks that are characteristic of human intelligence.
Okay.
So it's not about the internal mechanisms or the philosophy of it.
It's about the results.
It's about what it can do. Can it do things that we consider intelligent when humans do them?
So they had these kind of like these big ideas, back then.
Yeah.
But the technology itself, I mean, it was pretty limited.
Oh, absolutely. We're talking very early days. These systems were basically just running on code, very precise instructions.
Hmm.
And human thought, as we all know, it's messy, it's fuzzy, it doesn't always follow clear-cut rules.
Yeah.
So these early systems really struggled with things like language, right? Like translating languages, understanding the nuances of human conversation, or even just recognizing everyday objects.
You had that great example in your notes about trying to teach AI to recognize a cat.
Oh, yeah, the classic cat problem, right? You try to tell the computer, okay, a cat has whiskers, it has pointy ears, it's furry, it has 4 legs.
Hmm. But like cats come in all shapes and sizes.
Exactly. Siamese cats look very different from, say, a Persian.
Right.
And what about a cat that's curled up asleep? Or a cat in the shadows? There are just too many variations for a rigid set of rules to capture.
So it's just too simplistic, that approach.
Right. It could work in very controlled environments, like playing chess where all the rules are defined,
Mm-hmm.
but the real world is just too messy and unpredictable for that.
And that's where we get into the so-called AI winter, right?
Mhm.
Like when the hype died down and people realized these limitations.
Yeah, the late 80s, early 90s.
Yeah.
The funding dried up, people got disillusioned, and progress really slowed down.
Because they just couldn't deliver on the initial promises, right?
Exactly. But then things start to shift again in the 90s with machine learning, and this is a really fundamental change.
Yeah, this is when things start to get interesting.
Instead of trying to program all the knowledge into the machine, we start saying, okay, let's let the machine learn from data. We feed it tons of data, and it figures out the patterns and connections on its own.
So with the cat example, instead of trying to define a cat through these rules, you just show the AI a bunch of pictures of cats.
Right. Thousands, millions of pictures of cats in all sorts of different situations.
And it learns.
And starts to learn what a cat looks like, not through our words and definitions, but through its own analysis of the visual data.
That's so cool. So that's really what modern AI is all about then, right? Like learning from experience.
In many ways, yes. It's about creating algorithms that can improve their performance based on the data they're exposed to.
And this is where we see some really impressive breakthroughs, especially in things like image recognition.
Oh, absolutely. In the 2000s, the progress in visual object recognition was just astounding, and it's all thanks to this shift to machine learning.
And that example you gave about the MIT researchers, the AI that could predict which molecules would make good antibiotics, that was just mind-blowing.
Yeah, that's a great example of how AI can do things that we humans can't. It found connections between the structure of molecules and their antibacterial properties that no one had seen before. And it wasn't just following some predefined rules, it was finding these subtle probabilistic relationships.
So it was, in a way, more intuitive.
In a way, yes. It was like it had developed a kind of intuition based on all the data it had analyzed.
That's fascinating. Now, you mentioned neural networks earlier. Can you explain a little more about how those work?
Sure. So neural networks are inspired by the structure of the human brain.
Okay.
You have these interconnected nodes or artificial neurons, and the connections between them have different strengths, represented by numerical weights. And by adjusting these weights, the network can learn to perform different tasks. So, for example, in image recognition, the network might learn to recognize edges in the early layers, then combine those edges into shapes in the middle layers, and then finally recognize whole objects like faces or cars in the later layers.
Oh, I see. So like a hierarchy of features, right?
Exactly. And the more layers you have, the more complex the relationships the network can learn. And that's where deep learning comes in.
Ah, deep learning. I hear that term all the time.
It's basically just neural networks with many layers. And
Ah.
it's deep learning that has really driven the recent explosion in AI capabilities.
Okay, so how does this deep learning actually work? Like how does it learn?
Well, there are two main phases: training and inference. In the training phase, you feed the network tons of labeled data. So, for example, if you're training a network to recognize cats, you show it millions of pictures of cats, each labeled cat, and the network adjusts its weights to try and correctly predict the label for each image. And through this process, it learns to recognize the patterns that distinguish a cat from other objects.
Uh-huh.
Then, in the inference phase, you show the network a new image it hasn't seen before.
And it tries to predict what it is.
Exactly. And based on the patterns it learned during training, it might say, okay, this is a cat or this is a dog.
So with the antibiotic example, the researchers first trained the AI on a massive data set of molecules and their properties.
Exactly. And then once it was trained, they could show it new molecules and it could predict whether those molecules would be effective against bacteria.
That's pretty amazing. So there are different types of machine learning, right? You mentioned supervised learning earlier, but there are others too, right?
Yeah, so supervised learning, like we discussed, is where you have labeled data. You give the AI the input and the correct output, and it learns to map the two.
Okay.
But there's also unsupervised learning, where you don't give the AI any labels. It just has to figure out the patterns in the data on its own. And what kind of tasks can you do with unsupervised learning? Well, one example is clustering. So imagine a streaming service like Netflix wants to group its users into different categories based on their viewing habits.
Right.
They can use an unsupervised learning algorithm to analyze the data and automatically identify these clusters without having to explicitly define what each cluster should look like.
Oh, I see. So it's like the AI is discovering the categories for you.
Exactly. And this can be used for all sorts of things, like targeted advertising or fraud detection, where you're looking for unusual patterns in financial transactions.
That makes sense. And then there's reinforcement learning, right?
Yeah, reinforcement learning is all about training an agent to act in an environment.
An agent.
It could be a virtual robot or a character in a game or even just a piece of software.
Okay.
And the agent takes actions and it receives rewards or penalties based on the outcome of those actions.
So it's like learning through trial and error.
Exactly. And the goal is for the agent to learn a strategy that maximizes its reward over time.
And you mentioned AlphaZero, the AI that learned to play chess.
Yeah, that's a great example. AlphaZero wasn't taught any specific chess strategies by humans. It just played millions of games against itself. And through this process of trial and error, it figured out how to play chess at a superhuman level.
Wow, that's crazy. So these machine learning techniques are being used for a lot of different things these days, right? Like it's not just chess and image recognition anymore.
Oh, absolutely. Machine learning is everywhere now. It's being used in agriculture to optimize crop yields and detect diseases early on.
Hmm.
It's being used in medicine to discover new drugs, diagnose diseases, and personalize treatments.
Yeah, I've heard about AI being used to analyze medical images like X-rays and scans.
Exactly. And it can often detect things that human doctors might miss.
Wow.
And it's being used in finance for things like fraud detection and loan approval.
What about language translation? Like, I feel like translation software has gotten so much better in recent years.
Yeah, that's a huge area where machine learning has made a big impact. We've moved away from those old rule-based systems, which were often clunky and inaccurate,
Right.
And now we have these deep neural networks that are trained on massive amounts of text in multiple
And
languages.
they can actually capture the nuances of language.
Yeah, it's not just about substituting words anymore. These AIs can understand grammar, context, even tone to some extent.
That's incredible. And then there's this whole area of generative AI, right? Like AI that can create new things like text, images, music.
Yeah, this is where things start to get really interesting, I think. Generative AI is all about training AIs to create new content.
And how does that work?
Well, one popular technique is called generative adversarial networks, or GANs.
Jans, okay.
And basically, you have two networks that are pitted against each other. One network, the generator, tries to create realistic content, like an image or a piece of text. And the other network, the discriminator, tries to tell the difference between real content and fake content generated by the generator.
Oh, I see. So they're like competing with each other.
Exactly. And through this competition, both networks get better and better. The generator learns to create more realistic content, and the discriminator learns to be more discerning.
And what are some examples of what generative AI can do?
Well, we have things like GPT-3, which can write incredibly realistic text.
Yeah, I've heard about GPT-3. It's like it can write poems and code and even scripts, right?
Yeah, it's pretty amazing. And there are other AIs that can generate realistic images from text descriptions or create new music in different styles.
Wow, that's wild. And you know what else is interesting? Like how AI is being used to personalize our experiences online, like with search results and recommendations.
Yeah, that's another huge area. AI is now deeply integrated into how we find information and consume media. When you search for something on Google or when Netflix recommends a movie, there's a good chance AI is involved.
And it's all based on our past behavior, right? Like what we've
Yeah.
searched for, what we've watched, what we've clicked on,
Exactly. AI is constantly analyzing our data to try and predict what we'll find interesting or useful.
which can be really helpful, right?
Yeah,
Like it can save us a lot of time and effort.
absolutely. But it also raises some concerns about echo chambers and filter bubbles.
Right, because if we're only ever exposed to information that confirms our existing beliefs.
Then it can be hard to broaden our perspectives and challenge our own biases.
Yeah, that's a really important point. And it kind of leads into this bigger discussion about the limitations of AI, right?
Right.
Like, it's not all sunshine and roses.
Definitely not. AI is a powerful tool, but it's not a magic bullet. It has its limitations and potential downsides that we need to be aware of.
So what are some of the biggest limitations?
Well, one is the issue of explainability.
Explainability.
Yeah, like with traditional computer programs, you can usually trace the logic, right? You can see how the program arrived at a particular decision. But with a lot of modern AI, especially deep learning, it's more like a black box.
Mhm.
We know the input and the output, but we don't always know exactly what's happening in between.
So it's hard to understand how the AI is making its decisions.
Exactly. And this can be a problem in situations where we need to be able to trust the AI's judgment, like in healthcare or finance.
Hmm, that makes sense. And then there's the issue of bias, right? Like we talked about earlier.
Yeah, AI models are trained on data, and that data can reflect existing biases in society. So if you train an AI on a data set that's biased against certain groups of people, the AI is likely to learn those biases and perpetuate them.
And that can lead to some really unfair outcomes.
Absolutely. Like with facial recognition systems that are less accurate for people with darker skin tones, or loan approval algorithms that discriminate against certain demographics.
And it's not just about the data itself, right? Like even the way we design the algorithms can introduce bias.
Right. If you're not careful, you can inadvertently bake your own biases into the system. Like with that example of the pulse oximeter that was less accurate for people with darker skin because of the way it was designed.
So we need to be really careful about how we design and train these systems.
Absolutely. And then there's the issue of brittleness. Like AI systems can be really good at specific tasks, but they often lack the kind of general intelligence that humans have.
What do you mean by brittleness?
Well, like an AI might be able to recognize a cat in a photo, but if you change the lighting or the angle slightly, it might suddenly fail to recognize it.
So it's not very adaptable.
Exactly. And it can also make these weird mistakes that a human would never make.
Like misidentifying an animal as a gun.
Yeah, exactly. Because it's not really understanding the world in the same way that we do. It's just picking up on patterns in the data.
Hmm, that's interesting. And, you know, it kind of makes you wonder about the future of AI, right?
Yeah.
Like, where is all of this going?
Well, it's hard to say for sure, but it seems clear that AI is going to continue to become more powerful and more pervasive.
Yeah, like I can't imagine it just disappearing now.
Right. We're seeing huge investments in AI research and development, and there are a lot of really smart people working on these problems.
But it's also hard to predict how quickly things will progress, right?
Yeah, it's not like Moore's Law, where we had a pretty good idea of how fast computing power would increase.
Right.
With AI, it's more unpredictable. We might see sudden breakthroughs that change everything overnight.
So it's really an exciting time to be following this field.
Absolutely. There's so much potential for AI to improve our lives in countless ways, from healthcare to transportation to education,
But we also need to be mindful of the risks and challenges.
for sure. We need to make sure that AI is developed and used in a way that benefits all of humanity, not just a select few.
And that it's used ethically and
Yes,
responsibly.
exactly. So I think the key takeaway here is that AI is a powerful tool with enormous potential, but it's not a silver bullet.
Yeah.
It has its limitations, and we need to be aware of those limitations as we continue to develop and integrate AI into our lives.
So to kind of wrap things up, I guess the question for our listeners is, how do we want to shape the future of AI?
That's a big question.
Yeah, but it's an important one.
It is. AI is going to have a profound impact on our lives, and it's up to us to decide what kind of impact that will be.
So it's something we all need to be thinking about and discussing.
Absolutely. And I think the more informed we are about AI, the better equipped we'll be to navigate these challenges and make sure that AI is used for good.
Well said. So thanks for joining me on this deep dive into AI.
It's been a pleasure.
I hope you found it informative and thought-provoking, and I encourage you to continue exploring this fascinating and rapidly evolving field.
It's definitely a topic that's worth keeping an eye on.
Absolutely. Thanks for listening.
Thanks, everyone.